Oh, good morning, friends. Today, I, Dr. Rajput, welcomes you in my YouTube channel, Dayal and Sons Class of Clinical Sciences. In this new video, we are going to discuss some problems from section B of CSR Net June 2021 paper. So let's begin. Now, the first question is, the question ID is 721. And in this question, it was asked the order of penetrating power and ionization power of alpha, beta and gamma rays. Now, in order to understand this, let us first see the nature of these rays. Alpha ray is basically a positive ray, carries positive charge. Gamma doesn't bear any kind of charge, it's neutral. And beta is negatively charged, carries negative charge. Beta carries negative charge. Now, from this charge capacities, that is the positive, neutral and negative charge, it is clear that the gamma rays, no ionization will occur. Since gamma rays are neutral, that means no ionization will be occur. That means ionization power of gamma rays will be the least one. On the other hand, since it is neutral, it won't be reflected by the positive electron or the positive nucleus that a particular atom has, and so therefore the penetrating power, this also implies penetrating power is highest. For gamma rays, penetrating power will be the highest and ionization power will be the least. So now, next, in case of positive and negative charge, the positive charge causes more ionization, than the negative charge. Therefore, this means the ionization power of alpha particle, that is I alpha, if I denote it by I alpha, will be greater than I beta and least is for gamma rays. Now, since ionization of alpha particle is more, this also indicates that this has the least penetrating power. Therefore, we have already seen gamma is the highest, alpha has the lowest penetration, and beta. So this was the correct order in the question, and this was option number C. So the correct order of ionization is ionization of alpha particle will be the highest, followed by beta, and least will be for gamma rays. And simply opposite of this is for the penetrating power. The penetrating power of gamma rays will be the highest, followed by beta particle, and least will be for alpha particles. Okay, I hope this is clear. Okay, now let's move to next question. Now, next question is question number is ID number 745. Question ID is 745. Now in this question it was given us that the three phases are in simultaneous equilibrium and the system is a two component system, and this question was basically based on the phase rule. What is the phase rule? Phase rule says F plus P is equal to C plus 2. According to phase rule, degree of freedom plus phase rule, number of phases will be equal to number of component plus 2. Alright, now in this case, phase are given to us that we have three phase. So F plus 3 equal to. Now number of components are 2. So 2 plus 2. This means F is equal to 2 plus 2 is 4. 3 goes here, will be minus, and is equal to 1. So the number of degree of freedom for a system with three phase of two component system having three phase in the simultaneous equilibrium at a point that at that point the degree of freedom will be equal to 1. Okay, I hope this is clear. Now let's move to next question. Next question says, for a person weighing 70 kg, minimal volume of fatal dose of a compound with LD50, LD phases liquid dose, LD means liquid dose, will be of 80 must consider 80 milligram per kg. Per kg means for person weighing 1 kg, 80 mg of dose is required. Now, what we have been asked? We have been asked the volume, and we have been given that a minimum dose per kg is 80 milligram. So for 70 kg of person, for 70 kg person, total dose required will be equal to weight of the person into LD50, that is the dose per kg, is equal to 70 into 80 mg per kg. kg gets cancelled. What we are left with 5600 mg, or we can write it as 5.6 gram. So the liquid dose in weight it is coming out to be 5.6. Now what you've been asked, the dose in ml. Now the density of this dose is given to us is 1.45 per gram per ml. This means total dose in ml will be equal to density is equal to weight of dose divided by density, that is equal to 5.6 divided by 1.45 gram per ml, and this will give me around 3.86 ml, which is nearly equal to 3.9 ml. This was the required answer. It's 3.9 ml of dose is required for a 70 kg person. I hope this is clear. Alright, let's move to next question. So in these three questions, what we have seen, the option for answer for first one is R, gamma, R gamma, R beta, R alpha, and I alpha, I beta, I gamma. This was the answer for question ID number 751. 721, sorry. For 721, the phase degree of freedom comes out to 1, and here dose in ml will be equal to 3.9 ml. Okay, I hope this is very much clear. Alright, now we move to next question. The question ID is 741. In this question, it was asked the commutator of it was asked to calculate the commutator of x and px square. This particular question is a repeated question. It has also come in the previous year's Senate paper of December 2013 or June 2013. I'm not sure, but this is a repeated question. Now let's see how to solve this. We have to find the commutator of x comma px square, right? Now in order to solve this particular question, we will be using an identity of computation: a operator into b operator into c operator का commutator, a operator comma b operator into c operator का computation. This will be equal to b commutator of a commutator into c commutator plus a commutator into comma b commutator into c operator. Now if we compare this equation with this particular identity, how I can write this particular operation as px into px. I can write this as in this form. So from here what I see, that a is equal to x operator, b operator is equal to px operator, and c operator is equal to px operator. Now so what I can write is px operator into x operator into p operator plus x operator comma px operator will give me px operator, right? Now we'll use another entity. Another entity is that commutator of x and px is equal to of x comma px is equal to I h cut is equal to I h cut. Now so what I will do is I will replace in this equation commutator of x px by I h cut. What I will get, px operator into I h cut plus I h cut into px operator. Now this I h cut is a constant, so this can be written as I h cut px operator plus I h cut px operator. This implies this is equal to 2I h cut px operator x px square operator is equal, computation of this will be equal to 2I h cut into px. This was the correct option for this question. What we have done is, first we have applied this identity and we have got this form. Now we know that the computation of x px is equal to I h cut, so we replace this commutator by I h cut in both the places. Now when I write this as this, I h cut is a constant, so p operator working on x on a constant can be written as constant into operator, right? Now here is also IH cut PX, IH cut PX. We can add these two. It will give me 2IH cut PX. So this was the correct option for this particular question. Okay, now let's move to question number, next question, question ID number 739. Now question ID 739. Now this particular question has been asked from the pericyclic reaction, from pericyclic uh, chemistry. Is from pericyclic chemistry. Now let us see what it is. In this question, it was asking that this transformation example of which type of cycloaddition? Which type of cycloaddition? Which type of cycloaddition is this? In question, this was asked that this particular transformation is of which type of cycloaddition. Let us see here. I write it here to make it more clear. This sorry, this, right, and plus this is benzene. This is the benzene. Upon cycloaddition, what is happening here? Let us see what's happening. This attacks this position, this pi electron shift here, this shift here, this shift here, and this shift here. So how many pi electron shifting is taking place? 2 electron from here, 2 pi plus. Now in this particular, that is the dienophile. This is our dienophile, this is our ene. Now from this ene, how many electrons are moving? 1, 2 to 4 to 6 to 8. So 8 electron movement is taking place. So it is 2 plus 8 pi cycloaddition. So this is the product. This is 2 plus 8 pi cycloaddition. This is a 2 pi 8 pi cycloaddition. 8 pi electrons are coming from this ene and 2 electrons from the dienophile gives us this addition product, which is formed due to 2 pi plus 8 pi cycloaddition. So this was the correct option for this particular problem. Alright. It's clear. Okay, now let's move to next question. This question is from question ID 743. In this question, it was the number of microstate for the atomic term 4F. Now, we are given term 4F and we are required to find out number of microstates. The formula for calculating microstates from the term is equal to ml into ms, or 2l plus 1 into 2s plus 1. Alright, the formula for number of microstates for any atomic term is given by the formula ml into ms, where ml is 2l plus 1 and ms is 2s plus 1. ms is the multiplicity and ml is the orbit, 2l plus 1. Okay, now for 4f. Now for ms is 4, here we are given ms is equal to 4. Now for any term we have m and l. The term is written as, formula for term is m upon l, where m is the multiplicity, spin multiplicity, and l here is the orbital, total angular momentum. Now let's see total angular orbital. Now from here, if you compare with this, ms comes out to be 4. Okay, now we move to next question. Question is ID number 765. Sorry, question ID is 765. In this question, we have been asked about the geometries of the 3 metal complexes. One is of ruthenium 6 CO17b negative, osmium 6 CO18p negative, and osmium 4 CO16. We have been asked about its geometries. Let us see how to calculate. Now first, complex number first, Ru6 CO17b negative. Right? Now, in order to know the geometry, we need to calculate the total valence electron count. Now, the total valence electron count is the total number of electrons contributed by all these ligands as well as metal. Now, ruthenium contributes 8 electrons. One ruthenium contributes 8 electrons. They are 6, so 8 into 6 plus. One CO contributes 2 electrons, and they are 17, means 2 into 17 plus. Now, one boron contributes 3 electrons plus. Now, since we have a negative charge over the complex, so we add plus 1. So, plus 1 is added. If it had been plus 1, then it will be minus 1. Okay, is equal to 8 6 is 48, 17 to the 34, 3 plus 1 is 4, and this total will come out to be 80. 8 4 12, 12 and 4 16, 8 8 16, 7 8 86. Total valence electron count comes to be 86. Now, TV 86 for this complex, TV is equal to 86. This implies this must be an octahedral. Geometry must be octahedral. Now let us see for B1. Second complex is osmium 6 CO18p negative. Let us calculate total valence electron count for this complex. Osmium, again it contributes 8 electrons. There are 6 of them, so into 6. Again carbonyl contributes 2 electrons, they are 18, so multiply by 18. Phosphorus contributes 5 electrons. Plus, since we have a negative charge over the complex, plus 1 is added. This will come out to be 48 plus 36 plus 6, and this will come out to be 90. Total valence electron count is equal to 90, and this implies trigonal prism geometry. Trigonal prism geometry. Trigonal prism geometry. Now let us see for the third complex. Let me rub this. Third complex is osmium 4 CO 16. Now, total valence electron count is equal to 1 osmium contributes 8 electron. There are 4 of them, 8 into 4. 1 CO contributes 2 electrons, there are 16, to 2 into 16. This is equal to 32 plus 32, that is equal to 64. Total valence electron count is 64, implies square planar geometry. Therefore, for ruthenium complex, octahedral. For osmium P complex, osmium 6 CO18 P negative complex, trigonal prism. And for this we have square planar. And the reference for this can be found in Housecraft. Housecraft 4th edition self-study problem में. self-study exercises में. Alright, so this is all for today. In the next video we will see some more questions from CSNet June 2021. I hope you like this video. Thank you very much for your viewing. Thank you very much.